In this video we're going to look at some examples of stratiform cloud and their traces. So what you can see here is we have a satellite image that's slowly looping and the corresponding mean sea level pressure analysis. You can see that this is a March chart, so it's later into the wet season over northern Australia. The dot dashed line is the monsoon trough. There's a low to the northwest of Darwin. The trough extends down over northwestern Australia and into the Coral Sea, so there's a low off Queensland. There's a high in the Tasman extending a ridge through New South Wales and into inland Queensland. There's a low pressure system starting to move south of the Bight. If you look at the satellite image, then you'll see extensive areas of cloud over the tropical seas north of Australia, also over the east coast of Australia. And then there's evidence of that low progressively moving towards the Bight. You can see cloud wrapped around that and a cloud band ahead of it. The various red dots indicate locations that we're going to look at as we move about. What I'll get you to do is, as we change screens, to stop and look at the various images, and you might want to talk about it with your colleagues and have a think about, is there stratiform cloud? What are the bases and what are the tops? Is it low level? Is it mid level? Is it high level? Is there ice cloud or this liquid water cloud? So let's have a look through. This is Perth's trace. What do you see? What's the cloud base? What's the cloud top? Well, if you compare to the satellite image, it looks like there are some very grey shades which are indicative of low cloud. And if you look at the trace, the dew point depression is very large through most of it, except below about 3,000 feet. So it looks like there's a shallow layer, potentially of stratus then, where the dew point depression is small. You can see just above that is a region known as an inversion. We'll talk more about that in other videos. So there's low level stratus, or perhaps a cloud known as stratocumulus. So a stratiform cloud that has some embedded convective elements, but it's very shallow and it's very low. Let's move to Eucla. Well, this is altogether clearer that there's a saturated layer starting at about 10,000 feet and going up to 22,000 feet, and then there's some separation. There's a dry slot, a region of fairly dry air between about 22 and maybe 25,000 feet, and then a layer where the dew point depression is relatively small, and it might be the case that there's ice cloud through there. Again, the issues with frost point, etc. So there's definitely a layer of altostratus here, and embedded altocumulus, which is the convective variety. We refer to that commonly as ACAS, and probably some cirrus, some high-level stratiform cloud above that. Here's Mount Gambier, which is on the Victoria South Australia border. You can see what? The dew point depression is large through most of the trace. Above 30,000 feet, we might be tempted to say that there is some region of cirrus, and if you have a close look at the satellite loop, and you might want to go back to the original larger version, there's some hint there's a little bit of cirrus. Again, remember the difference between the dew point and the frost point. Here's Williamtown on the east coast of Australia in New South Wales, and you can see that there are various regions where the dew point depression is relatively small. So what kind of cloud do we have? Certainly there's some ACAS, there's some dry layers, so it's not continuous through the depth of the atmosphere, but again, it looks like we have altocumulus, altostratus, and then some gaps in it, and probably some cirrus all the way up towards the tropopause. That's Brisbane. Brisbane looks a bit more complicated. Again, there are multiple layers. Pause the video and work out where you think the cloud bases and tops are for each of these. This is Weipa up on the Cape York Peninsula, and this one's a bit more complicated. I would suggest to you that this is far more a convective environment than a stratiform environment. There are certainly layers where the dew point depression looks small. It's possible that there's some cirrus. You can see that blowing off the deep convection further to the north and east, but I suspect this is primarily a convective profile, and we'll talk about this more both in the thermodynamics course and also in the tropical meteorological course a bit later on in the year. Here's Broome on the northwest coast of Australia, and again there's some complexity there in terms of the dew point depression and therefore the relative humidity profile. Again, it looks much more convective, but you can get stratiform cloud out of that.